input. I'd like to hear you telling me what you think the next step is that we need to do to get our answer. All right, we're going to be reviewing Pythagoras, as it says on the screen here, SOHCAHTOA, the sine law, and the cosine law. Those are all the things that we did in the trig unit, and I want to try to get as much of that into this review session as possible. All right, so let's go to the beginning. Let me see if I can get this thing started. Let's look at these two triangles, right? Both of them are right triangles, and please remember that Pythagoras only works if we're dealing with a right triangle. So I'm going to point to, you should hopefully be able to see my mouse. I'm going to point to the triangle on the left and ask you, here's the formula for Pythagoras. By the way, all the other formulas are in the handouts that are available on the website. And when you're doing the actual test, you should try to make sure those formulas are close by to you. I'll probably put a formula sheet with the test as well, but it would be a good thing if you had the formula sheets from the handouts close by. So here's my first triangle. It's a right triangle. And I'm asking you for the length of this side that's marked X. So one of you, anybody who is participating, how would I set that up? I don't want to show you right away. I want you to tell me how you would set this up to solve for that missing X. Talk to me, anybody. Unmute your mics. I don't need anybody muted right now. We can all participate with our mics unmuted. So tell me what would be the first step in solving this? Anybody?
You put the X is going to be C squared.
Okay, so that would be your C then. All right, so we're going to square the X?
After you get the answer.
Okay, well, yeah, so we're going to square X. So what's X squared equal to then?
So it's 10 squared plus 24 squared equals.
Okay, so something looking like what I just put on the screen, right?
Yeah.
Okay, and of course we can easily with our calculators, hopefully have your calculators nearby, easily find what 24 squared is and 10 squared is. I'm putting that answer on the screen right now. You can verify that with your own calculator. Then I'm going to add these two together, which gives me 676. Now what?
You squared it?
You square root it. Well done. So there's a square root, and then you have your square root key on your calculator. The answer is 26. Now, please remember, one of the things that I'm going to be looking for is that you have units in your answer. And even though this question, I took this question from the That Quiz website, they don't have any units on here. I'm going to make sure that any question that I give you has units on it. So I'm going to be putting in units on my answers, even though the question itself didn't have any units. All right. All right. Look at the second graph over here now. Sorry, second equation over here. This equation, this triangle, I should say, sorry, this triangle is different from the first one. Can anybody tell me how this one is different? In what way? How is this one different from the first one? Anything that's different about this one's a right triangle as well, but what's the difference?
We don't see.
We don't have C.
We know C.
Oh, we know C. Oh, which side is C?
The hypotenuse, the
and
longest side.
Which is, well, how long is it in this case?
39.
That's the 39. Perfect. Okay, so we're going to set it up still with the same formula that I'm pointing to here. But this time I'm going to say this squared plus 15 squared is equal to 39 squared. In other words, when we had the first equation, we had the x squared by itself on one side. No, this time the x squared is with one of the other sides equal to 39 squared. So how do we now go from here to getting the actual answer? What would my next step be to get the answer? Help me through that. This is revision, so I think you guys should know or have an idea of how this works. What's my next step? Again, anybody. The people with their mics unmuted, you're welcome to turn your mics on and just sort of participate. Go ahead. What's my next step? I want to get the x by itself. I want to solve for x. So what do I do to solve for x? No? All right, let's do this then.
15 squared.
Say it again.
Subtract 15 squared.
From the 39 squared, so we'll do that.
Yeah.
So there's the 39 squared minus the 15 squared. All right, perfect. And then I'm going to figure out what that is. So take the 39 squared, take the 15 squared, subtract the two of them, gives me the x squared. And I'm going to assume that if we did that over here to get the answer, we know that to get the final answer, we have to find the square root. So I've done that, and there's my answer, 36 centimeters. So that's a quick review of the Pythagorean theorem. And I gave you two different instances, one where we're trying to find the hypotenuse, right? That's the missing side. And one where we're trying to find one of the shorter sides. When you're trying to find one of the shorter sides, you have to do a subtraction to be able to solve for that x, which is what we did for this one. Okay, SOHCAHTOA. Now remember what SOHCAHTOA means. It just means the relationship between the three sides, opposite, adjacent, and hypotenuse, is what, it looks like I left out something here. I left out the H here. Sorry about that. Is what this thing is trying to tell you. So it's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, all that good stuff. So look at the first one. Part of this is figuring out which one of them you're dealing with. Look at my first triangle and you tell me, it's a right triangle, which two sides am I working with? Tell me what these two sides are. I have a side here and I have a side down here. In relation to this angle, which is what they're giving us, what do I call these two sides? Anybody? Okay, let's start with this side. What's this side right here? What's the name of that side?
Hypotenuse.
Okay, what about this side down here?
Adjacent.
Great. All right, so of the three, sine, cosine, and tangent, which one relates with adjacent and hypotenuse? Adjacent and hypotenuse. All right. Everybody in agreement with cosine? Cosine makes sense? Okay.
Yeah.
So there we go. But just remember, it's not the cosine of a side. You never take the cosine of a side. So I don't want to see you taking the cosine of x or the cosine of 15. Those are sides. We always say the cosine of an angle. So in this case, it's the cosine of the 53. And look at what I did. I put the adjacent over the hypotenuse. So 15 goes over x, not x over 15. According to this thing, it says cosine is adjacent over hypotenuse. Here's my adjacent side. So that goes over this. So 15 over x. So here's the problem now. We need to isolate this x. Does anybody remember how I taught you to get that x on its own? How do I get x equals out of this? There's a term or a phrase I used when I'm trying to isolate x when the x is on the bottom. Does anybody remember what that is? No? Trading places. Yes.
Yeah.
Does that sound familiar?
Mm-hmm.
Okay, what does that mean? Trade places means take the x from where it is and trade it with the cosine of 53 and put the 53 cosine of 53 where the x used to be. So we're just going to switch positions of these two things. I find that's the easiest way to work this out. So what that will look like is this, that the x is now equal to the 15 over the cosine of 53 right there. All right, so the 15 is still on top, but that x gets traded with the cosine of 53, which is now where the x used to be, and the x is now where the cosine of 53 used to be. They've just switched positions. So when the x is on the bottom, I find that's the best way for you to set it up so you can solve for x. Now, this is ready to go. I can now solve for x by just, on my calculator, put the 15 over the cosine of 53. Now, before anybody does any calculation, what am I always saying you have to do first on your calculator before you go any further? Anybody remember? You want to check to make sure your calculator is in the right
45.
tan of 45. And what's the tan of 45 supposed to be?
1.
There you go. So check it right now before you go any further. On your calculator, hopefully you have one nearby, find the tan of 45. It's not equal to 1. So I'm not there with you to help you to change it to the right mode. But if you look around, I'm sure you'll figure that out on your own. All right, but make sure that the tan of 45 is 1. I hate when students do everything right and get the wrong answer because they just have the calculator in the wrong mode. So just check that first. Okay, now that you've checked it, hopefully, and hopefully it is saying that the tan of 45 is equal to 1, go ahead and find what 15 over cosine of 53 is and round that answer to the tenths. Now, tenths means 1 decimal place. Part of what you're being tested on is that you know how to round accurately. You might get the right answer, but round it wrong and lose a couple of, half mark here or there. So let's put that in the calculator right now, see what we can get. Zubair, I see you here. Can you tell me what your answer is when you put that into your calculator?
It's 24.925. 4, 6,
Okay, but give me to the nearest tenth now. Let's round that correctly.
25.
10th means 1 decimal place. I need one number behind the decimal point. When you give me 25, it means I have nothing behind the decimal point.
25.1.
I'm not sure if I agree with you on that one. Because what you told me, I'm put it on my calculator right now. 15 divided by the cosine of 53. Yeah, I'm seeing something different on mine. Because remember what we said, put your finger behind the number behind, okay, you want 1 decimal place, right? Yes? So put your finger behind the last number behind the decimal point, which is a 9. And then before you decide whether you're going to increase it by 1 or leave it as it is, peek behind your finger. And right now I'm looking at a 2, which is not 5 or more. So that means that 9 is going to stay as a 9. So what does that mean about the answer then? Somebody else, not just Zubair this time. Simran, how about you? What do you think? What's the correct rounding for that?
24.9.
So this is what we're looking at. Again, I'm putting centimeters. Even though this doesn't have any units on it, I'll make sure that your test has units on it. So yes, 24.9 centimeters is the correct answer for that one. Okay, how about this one? Look at the sides. I'm trying to find, again, the missing side over here. What would I call these two sides? Tyrell, you jump in and tell me. Help me out here. What do I call this longest side and what do I call this side away? Those are the two. Sorry, go ahead.
I don't even know stuff.
Okay, look at this side here. This is the longest side. What do we call the longest side again?
Is it like the obtuse or something like that?
Hypotenuse, yeah. So you're
Okay,
close, hypotenuse. All right, but we have another side. So that's what the 10 is. And remember, not only is it the longest side, the other way that you can figure out which side it is by seeing the one that's across from the right angle. Here's my right angle right here. Side that's furthest from it, that's my hypotenuse, okay? Now, what about this other side over here? Jad, I see you in the room. What about this side over here? What am I gonna call that side in relation to this angle?
Opposite.
All right, so we're talking opposite, and as Tyrell said, this is hypotenuse. So if I'm talking opposite and hypotenuse, which of the 3 ratios should we be talking about then? What do you think?
9.
Okay, so sine. Sine of what? Sine of 44, sine of 10, sine of x?
44.
There you go. So the sine of 44 is equal to x over 10. Okay, so there you go. And now this time the x is on top. That's not quite the same as this one over here when the x was on the bottom. We traded places over here when the x was on the bottom. How do we deal with it when the x is on top this time? Does anybody remember that? We're not going to trade places like we did the last time. There's a 2-word, just like we had a 2-word phrase for this one, there's another 2-word phrase I'm looking for over here when the x is on the top. And I'm trying to get that x on its own. Anybody remember what that is?
It's
Simran?
multiplying.
Say it again.
Cross multiply.
Well done, cross multiply. Okay, so we've cross multiplied, and this is what it looks like when you cross multiply. This 10 comes over here and multiplies with the sine of 44, so it looks like that. All right, so I need an answer now. Elijah, unmute your mic, put it into your calculator, and tell me what you're getting. And again, I want that answer to the nearest 10th. Help me out with that, please.
All right, I got like 6.94.
Okay, 1 decimal place. So that means I can only have 1 number behind that decimal point. So try again. 1 number behind the decimal point. You gave me 2 numbers behind the decimal point. I only want 1. Trying to round it correctly.
6.95.
Again, no. See? So my answer here is 6.9. You're giving me too many decimal places. If it says 1/10 means 1, you mean you stop after that 9. You have to peek behind the 9 to see what's there. Is it 5 or more? Then you have to increase it by 1 here, or you keep it as it is. You keep it as it is because you just told me 6.94. So because the 4 is not more than 5, I keep it as 6.9. Make sense?
Yeah.
Wait, so how do you calculate it?
Okay, so in your calculator, have your calculator there?
Yeah.
Okay, so put in the 10
Yeah.
times the sine of 44.
How do you do that?
And you press your equal sign.
You said sine.
Yep, so 10, and then you multiply. You can put it in brackets. Sometimes people use brackets, same thing. 10 times the sine of 44. Now you press your equal sign, tell me what you're getting.
440.
Whoa, all right, something is wrong, but did you check to see the tan of 45 was 1? Did you check that?
I don't think so.
All right, you're gonna have to
10
check that.
times sine.
Hit the tan of 45 and see if that's equal to 1. That's just a check to see if your calculator is in the right mode.
It's probably not because I'm using my iPhone.
Okay, you're going to need to get a regular calculator from somewhere. You should have one somewhere. I can't lend you one today because I'm not with you. So hopefully you can find a calculator from somewhere to get that done.
No, probably from dollar store or something.
All right. Okay. I'm going to continue, but at some point, maybe later on today, I'm going to post this on YouTube, and I'll give you a link on the Math Video Library page. You can go back and look at it and try your calculator with it at that point and make sure you're getting the same answer, okay? I'm going to move on now. So, how about this one? Now, how is this one different? Let's just back up a little bit here. How is these two questions? Look at these two questions. One was cosine, one was sine. I had to find an x. I'm trying to find an x here again. But how is this x different from the x that I was looking at before? What's the difference? What's the big difference? Simran, what do you think?
Finding an angle. not
There
a
you
side.
go. There you go, not a side. All right, so anybody, what are the two sides? Tell me what two sides. Keja, how about you? What do you call the two sides that we're working with here? Let me point to this one first. What's this side over here?
The hypotenuse.
How about this one over here?
Opposite.
Great. Okay, sorry about that, folks. All right. Okay. So sorry about that. I'm just going to put this on mute here. Okay. So you just gave me the two sides. You said this is opposite, this is hypotenuse. SOHCAHTOA, which one? Sine opposite or sine, cosine or tangent?
Sine.
Okay, so let's set that up. Sine of, is it 27, 11, or x? Which one?
X.
Good. So the sine of x is equal to 11 over 27. There you go. And no, this is different from the ones that we had before, because when we're trying to find a side, we have to, cross multiply and sometimes trade places. Now the sine of x is equal to 11 over 27, but I want just x. I don't want the sine of x. So can somebody suggest, Jad, how about you? Can you suggest what I need to do next to find what x is? I don't want to find sine of x, I want x.
Sine to the -1.
Okay, there you go. So that x is equal to sine to the -1 of 11 over 27. So if I want to get an x on its own, I need to find sine to the -1 of the 11 over 27. So you need to, on your own calculators now, and by the way, this says round to the nearest whole number, do exactly that. All right? So there's only a few of you in the room, so I'm going to have to call on one of you. Elijah, you have your calculator nearby? Unmute for me, please. All right. You look for your sine to the -1 key, and then you enter in 11 over 27. I'm not putting the answer yet because I want to hear what you have. And remember that it says to the nearest whole number. So part of this is, how do I round this thing properly, right? How do I round this thing properly? So Elijah, talk to me. What are you getting when you put the sine to the -1 over 11 over 27?
I don't see Elijah.
Oh, I thought Elijah was there. Hang on one second. All right, anybody then. Doesn't have to be Elijah. What is sine to the minus 1 of 11 over 27? It's not about me just showing you answers. It's about you doing this for yourself. So you're trying to get the practice so that you can be ready for the test. So you put that into your calculator, and anybody can pipe in and tell me what you're getting. And by the way, I need this answer to be to the nearest whole number. So no decimals, just the whole number. All right?
24.
So you mean that? Excellent. Well done. Okay. And by the way, notice that I put my degrees in. Again, I'm stressing. It's important for you to put in your units. If it's centimeters, you put centimeters. If it's meters, you put meters. If it's degrees, put degrees. All right? Okay, so that's good. Now we're going to get to sine and cosine law. And I know that some people were saying that they were having some trouble with, I think, the sine law or whatever. Let me look at the first one. First one here is 3 sides. And remember, sine law and cosine law are what you use when you don't have a right angle. There are no right angles in this triangle. In fact, what I have here is 3 sides. I have no angles at all. One of the things I said to you is if I'm trying to decide between sine law and cosine law, I'm going to repeat it. Look for a matching side and angle. In other words, where do I have an angle opposite to a side where I know both of them? Do I have that in this case? I'm looking at the first triangle here. Do I have an angle opposite to a side where I know both the angle and the side? Anybody? Do I have that for this triangle here? Anybody see any angle opposite to any side where I know both the angle and the side?
No.
No. So we're going to have to use not the sine law, but the cosine law. So for this one, the cosine law is when we're trying to find a missing angle. You should have that formula on your formula sheet somewhere. I'm going to set it up for you and sort of walk you through it. So I'm trying to find x. This is the missing x. This is the angle I'm trying to find. So the cosine of, I said cosine law, the cosine of x is equal to the 2 sides that are around the x, right next to the x, so the 24 and the 14. When I square those two and add them together, minus the side that's across from the x, right, which is the 27, minus that side squared, and put all of that over 2 times 14 times 20, 2 times these 2 sides right here. That is how we would set it up to solve it. Now notice that I didn't use the 24 and the 27 and add those 2. I took the 24 and the 14 because these are the 2 sides that are right next to the side, the angle I'm trying to find. The one that's across from the angle, which is the 27, that's the one I'm going to subtract. So it's this squared. Hopefully everybody can see my mouse as I'm moving it around. It's this squared plus this squared minus this squared. That's the 24 plus the 14 minus the 27 over the 2 times the 24 times the 14, right? So all I need to do now is work out all of this stuff here on my calculator. And that's what my next line says. If you did all of that yourself, and you can do that for yourself, and you have your calculators there, you get 43 over 756. You can double check because I could have made a mistake. That's possible. But this is what my cosine of x is equal to, 43 over 756. But again, I'm not interested in cosine of x. I'm interested in x. So how do I move from the cosine of x is equal to this to actually getting x? What's my next step? Anybody, you can unmute your mic and talk to me. Go ahead, Simran. I see you just unmuted. What's the next step in the process here?
Would you cos -1?
Absolutely. Anytime you're trying to find a missing angle, excuse me, there's always a -1 in it somewhere, a cos -1, a tan -1, a sine -1. It's always what's called the inverse angle, inverse relationship of the cosine, sine, or tangent. So yes, you're absolutely right. So x is equal to cosine to the -1 of that. And again, you just have to put it on your calculators now, right? I'm not there to sort of walk you through what to do on the calculator. You have your calculators there. You hit your cosine to the -1 key. Usually it's a second function before you hit the cosine key. Then you put in 43 over 756 and hit your equals. So again, this is asking for to the nearest 10th. I'm reminding you what 10th is. 10th is 1 decimal place. So let's see who can get that answer, not just the right answer, but correctly rounded. All right? Anybody. I don't need anybody in particular. I don't want to have to call on anybody in particular. So you tell me, when you put cosine to the -1 of 43 over 756, give me to the nearest tenth, so 1 decimal place, please. I need 1 decimal place from you. Anybody? Keisha, how about you? You have an answer that you think might
I
work?
got 86.7.
Well done. I noticed, by the way, that you correctly rounded it to 1 decimal place. You looked at that last number, saw it was a 7, and said, should I bring that up or should I keep it? I looked after the 7, I saw 3. That means I should keep the 7. So you're absolutely correct. All right, let's look at the next triangle over here. This triangle over here, again, is not a right triangle. Do I use cosine law again? Do I need to? Or do I have a match? Do I have a side and an angle opposite to each other where I know them both? Do we have that? Jad, what do you think?
You have a pair.
Which pair do I have?
12 and 45.
Absolutely. So that means we can use the sine law. Let's set it up with the sine law. I'm going to say that the sine of this angle, right? I'm trying to find an angle so the angles go on top. The sine of this angle over the side opposite to it, which is a 16. So the sine of x over 16 is equal to the pair that you just gave me that I know. The sine of 45 over 12. Sine goes on top, side goes on the bottom. When I'm trying to find an angle, I prefer to put the angles on top. Okay, what does my next line look like? Amari, I see you there. Unmute your mic and tell me what my next line should look like. What's the thing I need to do to get the sine x by itself? Looking for a 2-word phrase here. What do you think?
You would have to put, like, you have to do cross multiply.
Oh, you mean that? Well done. So what is it going to look like after you cross multiply?
It's a 16 sine, 16 sine 45. And then it'll have sine 12 on the bottom.
Over 12.
Yeah.
Okay, well done. Well done. Now, here's the thing. I can work out what this thing is. This thing here is. I don't really care so much what this is because this is not my final answer. It's a sine of x that's equal to this. So here's what I'm going to suggest to all of you. Don't actually work this out. Just say that x is going to be equal to sine to the -1 of whatever this is. All right? Let me move this over here on the side a little bit. All right? So I need to just simply write it out this way. So when I go to my calculator, I'm going to put this in because it doesn't really matter to me what 16 sine 45 over 12 is, because I'm going to have to find sine to the -1 of that anyway. Does that make sense? Keisha, how about you? Does that set make sense?
Yeah.
Okay. So in your calculators, I'm suggesting you actually put the sine to the -1, open a bracket, like, around this, and then put in the 16 sine 45 divided by 12, close the bracket, press your equal sign. I want this answer to the nearest 10th. So who is going to give me that number? Help me out here. What number makes sense? 1 decimal place.
70.5.
Degrees. Don't forget that degree sign right there. That's important.
Do we have to put in the units when we're doing the online tests and stuff?
Yes, you do. Yes, you do. Now, we're going to get to the online test. So I'm glad you asked that question because I want you to see what that looks like. But I want to do a few more examples of this as we go along. All right? Okay, so let's get to the next one. Sine and cosine law again. But now we're trying to find sides. This is different. The one that we just did, we had to find some missing angles. Now we have to find a missing side. Okay, first one, sine law or cosine law? That's a big question. That is the big question. Who wants to help me out with that one? Keisha, what do you think? Sine law, cosine law? Simran, what do you think? Sine law, cosine law? Jad, anybody? You're saying, why are you saying sine law?
Because
you have a matching pair.
Tell me what the matching pair is.
10 and 75.
Excellent. So we're going to use the sine law, but the only difference this time is that the x now is on is the side. We're going to put the sides on top this time. So let's see if we can set this up. So it's the x over the sine of the angle opposite to it, which is 60 degrees, is equal to the side on top again over the sine of the angle that is across. Ooh, I made a mistake. I just realized I made a mistake. This is supposed to be 75. My answer is going to be wrong. Folks, I'm going to apologize right now. You need to work this answer out for yourself because my answer is going to be wrong. I have 75 here. The question actually, I have 45. The question was actually 75. So pardon my error, but this answer is not going to be right anymore. But then you can finish the question. You can cross multiply, right, which is what the next step is. And then you can do this 10 sine 60 over the sine of not 45, but actually 75. So my fault on that one. I apologize for that. You can finish that up. What I'll probably do is, thing is I'm recording this now, so I'm actually recording it with the error in it. You can fix that for yourself when you're trying this on your own. Just change that 45 to a 75, okay? And I'll give you an answer, but this answer is not going to be the right answer anyway. So don't pay any attention to that answer. Only that I do put units into the answer. So please remember to do that when you're doing it. Okay, next question over here. Look at this triangle. Do we have that match that we're talking about? Do we have that sine? Sorry, do we have that side opposite to an angle? Do we have that? What do you say to that? No, we don't. We don't. So if we don't have it, what are we going to use?
Cosine.
There you go. Here's what the cosine law is going to look like. This side squared is equal to these two sides squared minus 2 times those two sides, the cosine of the angle in between them. There's your cosine law set up for finding a side. Now we did use a cosine law on the previous slide to find an angle. It's a different setup, but for this one, you're using the cosine law to find a side. And that's what it looks like. This squared plus this squared minus 2 times that, the cosine of that. Really all you need to do is to find out what this is. Again, I don't really care. You see what I did here is I just put, it works out to 24.57. And I put some dots there because this isn't really my final answer. That's my x squared answer. I need to do something else to come up with the actual answer. And what's that last step again? What do you say is that last step?
Square root.
You square root it. Perfect. So let's do that. Square root of that, and my answer is 5.0. Now you notice that I put 0.0 because again, I want one decimal place. And if it's not exactly 5, then I need to put a 0 there. I think it worked out to be, what was it, 4? Let me see if I can figure that out quickly. 24.57. Just to get my calculator out. 4.9. Okay, so because that 9 has a number bigger than 5 behind it, I had to take that 9 and increase it by 1 to 0. But of course, if I increase that to 0, the 4 has to go up by 1 as well. That's why it's 5.0. Try that for yourself and make sure you're comfortable with the way I wrote that answer down, 5.0 centimeters. Okay. Now, we're going to be going over to teacher ease in a minute. I'm going to start my teacher ease and show you what your test is going to look like. One of the questions that you're going to see is going to look something like this one. So we're going to do the question here first, and then I'm going to go over to teacher ease and show you how you can do a similar thing when you're actually working on the test itself. All right. So we'll do it here first in this format, the PowerPoint that I'm using now. Then I'm going to log into teacher ease and show you the same question again and how you can enter your answer using teacher ease. Okay, but before we get to teacher ease, what are we going to use for this? Is this sine law, cosine law, SOHCAHTOA, Pythagoras? What are we using here? Waiting for an answer. Anybody can chime in.
Cosine law?
You know what? You probably could use a cosine law, but I wouldn't use, when you say cosine law, do you mean SOHCAHTOA? Because that's really what we should be doing here, right?
Oh.
And it's really not cosine law either, because these two sides that I'm looking at, right, neither of these is the hypotenuse, right? This is my opposite side. This is my adjacent side. So since I'm using opposite and adjacent, what should I be talking about here? Look at SOHCAHTOA now. Think about SOHCAHTOA. So it's either sine, cosine, or tangent, one of those three, that uses opposite and adjacent.
Sine.
No.
Mm.
SOHCAHTOA. Sine is opposite of hypotenuse. I don't even have the hypotenuse here. That's not part of this. It's tan. So the tan of x, again, you don't find the tan of a side. Tan of the angle. So what we're trying to find is equal to the opposite side over the adjacent side. So 26/19. That's exactly what I have here. So the next step, of course, we've done something like this before, is that x is equal to tan to the -1 of 26/19. And on your calculator, if you did that, you'd get 54 degrees. It does say to the nearest full degree. So if you go through and work that through, you should get 54 degrees from that. Okay? All right. Now, there's some other questions. There's this other question that we can just quickly look at before I go over the teacher ease. I want to make sure everybody's on the same page with me. What will I use for this one? Is this SOHCAHTOA again? Do I use SOHCAHTOA here again?
No,
No? Why not?
because it's not a right angle.
Absolutely. So because it's not a right angle, it's either going to be sine law or cosine law. Which one? Come on, Amari. Take off the thing on your mic. Unmute yourself. I just unmuted you, Amari. Talk to us. Which of them?
Wait, what are you asking me again? Sorry.
I'm asking you about this triangle. Sine law or cosine law? We agree that we can't use SOHCAHTOA. Is that sine law or cosine law?
That's a sine.
Why do you think it's sine?
I think it's sine because
We have that match. We have the match of the side again, opposite the angle. Do we have that?
yeah.
No. Which
Or no.
angle? We have no angles.
Oh yeah.
Mm.
You have the match coming through the 128 centimeters and 187.
No, those are not an angle and a side. They're both sides.
I mean,
All right. We need an angle opposite to a side. And we have no angles whatsoever. So what does that suggest to you then if we have no angles whatsoever? Sine law or cosine law?
it's cosine.
Yep, there you go. So there's a setup for the cosine law. Now, let me switch over. I'm going to stop this for a minute. And I'm going to just get my teacher ease account going and show you where to go for your test and what's the same two questions that we just looked at, what they're going to look like in teacher ease. Okay, just give me 1 minute here. Okay. Right, okay, all right. So I'm going to come back to my session here. And here we go. Okay, so I set something up for all of you to try out, and I'm going to log in as if I was one of you. The first one here is Ryan. I don't think Ryan is in the room anyway. I'm going to log in as if I'm Ryan, and I want you to sort of follow along to see what you're going to see when you start your test, okay? So you see a bunch of stuff here. Mr. Kamak sent an email. I'm going to go to assignments. And by the way, everybody can see my screen. I just want to make sure you all see my screen. Just chime in for me, please. Can you all see what I'm looking at in Teacher Ease?
Yeah,
Yes?
I can
Yeah.
Okay, perfect. All right, so you click on assignments and it says online document and it says work. So you're going to get started on your test now. You're going to log in promptly at 6 o'clock on the day that you chose. And here's a document that comes up. Now notice that this looks a lot like, I'm going to make my screen a little bit bigger so that you can probably see it a little better. Okay, this looks a lot like what you just saw a few minutes ago. This is the same question. So you're probably wondering, so how am I supposed to show you my answer? It's very simple. Do you remember what we used to get this one, by the way? Was it SOHCAHTOA, sine law, cosine law? Anybody remember what it was again for this question? We just did this question a few minutes ago.
Tan.
It was tan, right? Okay. So I'm going to set this up now for tan. And here's all I need to do. Click anywhere inside of the screen. When you click inside the screen, a little text box pops up. And I'm going to write down exactly what we just did in the PowerPoint presentation. We said that the tan of x was equal to We said it was 26/19. Now, for when you want to put something over something else, just use a little backward slash or forward slash, I guess. And there you go, right? So that's one line. And I can come down here and I can say, therefore, and I don't need every single line spelled out. You can still have your piece of paper on the side where you're doing your scratch work. All I needed to do is set up the first step so that I can see that you knew what you were doing, and then you can go from there. When we were doing this in PowerPoint, we said that x was equal to the tan to the minus 1 of, oh, I put it in the wrong place, tan to the minus 1 of 26/19. Okay, so I'm showing my work, but I don't have to show every single step. As long as you show me the first step, I'm good with that. So on your next line, you can just put in the answer now. So x is equal to, I'm going to grab my calculator again because I forget what the answer was. Tan to the minus 1 of 26/19, sorry. It was 53.8. Guess that's what we got the first time. Or no, 54 degrees. 54. Now here's the problem with the only one problem I have with the teacher is that you can't actually put the degree sign in, or maybe you can. I didn't look at this font family thing here. Maybe you can, but just put the word degree in. That's good enough for me, all right? And just put DEG for degree, that's good enough. So there's how you're gonna put your answer. It's really that simple, right? I'm gonna be able to come in later and mark all of this. So it's almost as if you're writing it on a piece of paper, but you're putting it in teacher ease. All right, let's go to the next question. How about this question here? We had started it, but we didn't actually finish it. What did we say we're going to use for this question again? We just did this a few minutes ago in the PowerPoint presentation. It's the same question. You notice that it has all the same numbers in it. So what did we say we're going to use to get the size of x when we did this a few minutes ago? Anybody remember?
Cosine.
Absolutely. So we can write that down. Cosine of x equals, then I'm going to put a little bracket here. So I'm going to put the 128 squared. To put squared, you can put that little up arrow thing that you saw me just put there, plus 187 squared minus 95 squared. I'm going to close my bracket. I'm going to divide that by everything that I just said it was before, 2 multiplied by 128 multiplied by 187. You can use brackets for that as well, but I did that wrong. Yeah, no, that's good. So all I need is that first setup. I don't need you to go through a lot more than that, right? I've just showed, what I did is I set it up, and then I can just go ahead and solve it from there. I don't need every single line. Does that make sense, everybody? How are you going to write your answers out?
Yeah.
Yes? Okay. So on your next line, just put your answer in, x equals, right? You get your calculator out, you figure it out, put your answer in. All I need is a setup. And from the setup, you can put your answer in, all right? Now, let's do a few more questions since we have about maybe 15 minutes more. Let's see if we can go through. Now, remember, I'm going to be putting all of this on YouTube later on, so you can go through it at your own leisure. But let's see if we can just finish up by getting a little bit more practice for the next few questions. The questions on your test will look a lot like these. So I want to find the measure of the unknown side. This is what I'm trying to find, this side right here. Anybody? SOHCAHTOA, what do you think? SOHCAHTOA makes sense for this? What do you say? Or should I use sine law or cosine law? Simon, what do you think? Simran, you there?
Yeah, it's a SOHCAHTOA.
Okay, good. All right, so she's right. Keja, what do you think? What do I use for SOHCAHTOA? Do I use sine, cosine, or tangent? Look at the two sides. I have this side here, I'm trying to find, I have this side over here that I know. This angle is this angle right here. So what do we call the two sides that we're going to be playing with? This side here and this side here. What do you think?
Hypotenuse and
Good.
opposite.
If it was opposite, it would be all the way over here, right? But the side I'm trying to play with here is this side that's right next to the angle that I know. So this would not be opposite, but what's the other one?
Adjacent.
There you go. There you go. So we're talking hypotenuse and we're talking adjacent. Jad, tell us now, if we're using adjacent and hypotenuse, how should we set that up?
For 2A.
Yeah, for 2A. Sine, cosine, or tangent?
Sine.
Okay, so let's write that.
Yeah, sine.
You think it's sine? I don't think it's sine.
No, it's cosine, cosine.
Okay, let's set it up then. So the cosine of what? Is it cosine of 46, cosine of 33, cosine of x, cosine of what?
33.
Okay, it's always a cosine or a sine of a side. So cosine of 33 is equal to what goes over what? Which side goes over which side?
Hold on. Okay, so you put the x over 46.
Except cosine is adjacent, which, remember what KJ just told us, adjacent is this side over here, over hypotenuse.
Oh, hold on, I was looking at it wrong. Yeah, my fault.
Okay.
Okay, so adjacent,
Which is 46
yeah,
over
and x.
the x. Perfect. Perfect. Okay, so this is when we would use that trading places thing I always told you about, right? Again, I don't need every single line. So on your piece of paper that's nearby to you, you can go ahead and write it out. But I'm going to write it here since we're all working together here. I'm going to say that the x is equal to the 46 divided by the cosine of 33. All right. Whatever this is going to be my answer to one decimal place. I'm going to leave that and move on to the next one because I want to get as much done in the time that we have left. Is everybody clear on what we just did? Does all of this make sense to you? The question isn't finished, by the way, so you can finish that up on your own, right? And make sure it's to one decimal place. That's important as well. In fact, you know what? Since we're on it, let's just do it because the rounding thing is also important. So I'm going to put it on my calculator and ask one of you to tell me what 46 divided by the cosine of 33 is. So 46 divided by the cosine of 33.
54.8.
And that's one decimal place. Well done. So x equals 54.8. And this is in centimeters. I'm putting in my units, centimeters. Okay. All right. Let's do two more in the time that we have left. How about this one? And then we're going to have this one. Now for this one, I'm going to give you the drawing and ask you to label the drawing because you can't draw any lines in the teacher ease. So I'm going to give you the drawing and ask you to finish that up with the rest of the information. But let's just go back to this one. Sine, cosine, tangent, SOHCAHTOA, sine law, cosine law, Pythagoras. What are we looking at here? Anybody?
Sine law,
Tell me why you think sine law.
because there's a match.
There you go. There's a match right there. 24 degrees, 3.8 meters. So we can use the sine law. Should I put the side on top or the angle on top?
Side,
The side, because that's what I'm trying to find. So I'm going to say that x divided by the sine of 87, right, is equal to, so I put the side over the angle, so that's this side over this angle is equal to what over what now? Somebody tell me.
If we were finding an angle, it would be the other way around.
Yeah, we put the sine of the angle on top.
Okay.
Okay, but now we're trying to find a missing side. So put the x, which is the side, over the sine of the angle, which is this, is equal to, okay, so what goes on top now on the other side of that equation? Anybody?
3.8
Good.
over the
Divided
sine
by.
of 24.
Nice, well done. And here's where we're going to cross multiply in the next line. Again, you don't have to show me every single step, so you don't have to show that, but I'm going to put it in since we're here now. So x, this is where you cross multiply, is equal to 3.8 multiplied by the sine of 87. And all of that divided by the sine of 24. Okay, so I'm cross multiplying. I'm taking the 3.8 multiplied by the sine of 87 and dividing by the sine of 24. All of that would represent the next step in finding that. And then you can go through and work that out and put your answer in here. I want to get to the next one. Now, like I said, unfortunately, you don't actually have a triangle here for you to be able to label it and say this is what my triangle is. It says sketch and solve. So what I'm going to do for you on the test is I'm going to put a triangle here, and then you're going to label it according to these numbers. So put a label for A, a label for B, and a label for C for the corners of the triangle. And then where it says angle B is 37, you can just put a 37 beside the angle. And where it says side A is 7.5, you can put a 7.5 in for that. So I'm going to actually, and by the way, what does it mean by solving a triangle? Anybody remember that solving a triangle, what does that actually mean? What does it mean to solve a triangle?
Wait, when is our test again?
It's either Wednesday or Thursday.
Next week?
Oh no, coming up this week.
What? What time?
It's 6 o'clock in the afternoon.
I have work.
Okay, well, we can figure something out. We can figure something out. All right, so like I said, I can't put anything in here for the triangle. We can probably go back to the PowerPoint for this one, and then we can probably finish up on that. Oh, actually, you know what? Let's do this. Because we only have 5 minutes left, let's look at this last one here. This is an application question. And there will be an application, at least one application question on the test. What I'm going to do is when I'm finished this, I'm going to take the same questions that we're looking at now. I'm going to write out solutions for them, and I'm going to post them on the website so that you can see. So I'm going to post this session, the Zoom session that we're doing, and I'm also going to post the answers to all the questions in this practice thing that we've just done. Okay, you can look out for that later on. But we'll finish on this one here. Two boats leave a harbor at the same time at an angle of 83 degrees to each other. One boat travels a distance of 49 and the other travels a distance of 62. How far apart are the boats? Round answers to one decimal place. Okay, if the harbor is here, boat 1 is here, boat 2 is here, can anybody tell me where this 83-degree angle needs to be? Because I'm going to put that on the diagram. Anybody, where is this 83? And where is this 49 and where is this 62? If I got this question and I had to label this diagram, how could I locate the 83, the 62, and the 49?
Wait, so the 83 would be in the inside, right?
Okay, where? Is it this angle, or this angle? Which of these angles?
Would it be like near the harbor?
It's actually at the harbor. So right here,
That's what I mean.
yeah, that's where my 83 is. Okay, good. How about the 62 and the 49? Those look like they're sides. Where should I put those numbers? The 49 and the 62. What are you thinking?
So it'd be like one we at
There are 3 sides here. There are 3 sides here.
All I know, it just goes to one of them goes to boat 1, the other one goes to boat 2.
Okay, should it be this line in the middle between them, or this line from the boat 1 to the harbor, or this line from the boat 2 to the harbor? Which line am I putting? Let's say the 62 or the 49. Would be a good place to put that 49.
It would be boat 1 to the harbor.
Well done. Let's put the 49 over here. So 49 km.
And then it would be 62 km to harbor to
From the boat 2.
2.
Good. So 62 km. By the way, just so you know, anything you put in here, you can delete. If you put your mouse over the thing you put in, and you see a little rubbish bin beside it, you can just delete it if you don't want to put that there. I'm going to put it back because that's what
Wait,
looks
I have a
right.
question.
Sure,
Are you going to be marking it, or is
I
it
am.
like
It doesn't
okay.
mark itself. No, I have to
Okay.
mark it. So
Okay.
when you're finished, I'm glad you asked that question. Let me go back here. Let me delete
Wait,
this.
the test will be on teacher ease, right?
It will be on teacher use, yes. You log into your teacher use account and look for assignments and you'll see it there. At the top of this test, I'm glad you asked the question. You'll see where it says hand in now. When you're finished and you're sure that everything is good to go, is when you press that hand in now button. Okay. Work more later would not apply to you because that would be if you're going to stop and then come back. This thing goes from from a set time to a set time. So you want to make sure you finish it within the time that is allotted to you. So at the end of it, when you're 100% sure that everything is good to go, is when you press the hand in now. That will send it to me, and I can look through and I can mark your test later on and put your marks into teacher ease. Okay? So that's how that works. And so we're coming up to the end of this, but I want to ask one last, let me put the 83 degrees right back in the middle here. So 83 degrees. Oh, that looks a little messed up there. Anyway, you know, it's 83. Which would I use for this one? Sine, cosine, or tangent? Or is it sine law or cosine law? It's one of them. Get rid of that. 83. Why is it so messed up here? Oh. Yeah, anyway, I'm trying to get the 83 to look a little better than that. It's not coming out so nice. Anyway, which one do I use? Sine law, cosine law? It's one of them. I'll give you a hint. See the sine law or cosine law. This 83 belongs right here in this corner right here. Sine law, cosine law, which one?
Wait, so like cosine law is when it's the opposite or the same?
No, okay, it's all right. So here's what the situation is. I don't know why this I'm trying to put a really nice, put it over here then. 83. Okay, let me move that over here. This is actually the cosine law. This is not SOHCAHTOA. And the reason for that is that I have a side here, opposite to an angle, I don't know the angle. I have a side here, opposite angle, I don't know the angle. I have an angle, opposite to a side, I don't know the side. So I don't have the match. And that's why, because I don't have the match, I'm going to have to use the cosine law. So does that make sense, everybody?
Yes, it does.
Okay, so this is the cosine law. All right, I'm going to leave you to set that up. As I said, I'm going to work this all out for you. Put the answers online. You're welcome to come back to me with questions. Some of you have been communicating with me by email anyway. Come back to me with questions that you have, and I'll respond to them as quickly as I can. And we'll try to see if we can get everything done in time for, most of you opted for the test on Thursday, so you have another day to prepare for this. And we'll try to make sure you have all the questions answered before we get started. Okay, so look out for this recording of this session, which I'm going to do after I stop the meeting, and look out for the answers to this all written out and posted on the website. So you're going to have a video, and you're going to have answers to all of these questions written out nicely so you can review it as well.
Wait, so is it ending right now?
I'm about to end it. Unless you have any more questions for me, I'm about to end the meeting. Yes. You wanted to ask something else?
No, I was just wondering.
Yeah. I don't want to wear you guys out too much. So I'm trying to make sure we keep it into, digestible, small sessions like this. So we're going to do this again at some point. Next week, I'm probably going to be posting some videos for the next unit. And I'm going to invite you on YouTube. I'm going to invite you to stay tuned for that. I'm going to send an email out once I've created the videos. And then you can go and watch them. And if you have any questions, you can certainly put comments at the end of the YouTube. You can put comments on YouTube videos, or you can send me an email and I will try to get back to you as quickly as I can. Don't panic. This is not meant to be a difficult test. I'm trying to give an idea of what to expect. So let me know if you have any issues, and we will try to get everybody on side. Okay. Everybody okay now?
Yeah.
All right. So we'll talk again soon. You take care. I'm going to close out the meeting now.